Okay, so today we'll solve mathematics GATE 2022 question from ODE. This is a question number 20. It is saying that if the eigenfunction corresponding to distinct eigenvalues of lambda of the Sturm-Liouville problem, the following, this one, with periodic boundary condition. It is saying that if the eigenfunction of this Sturm-Liouville problem are orthogonal for different eigenvalues lambda with respect to the weight function w, then you have to find what will be the weight function. So 4 options are given. You have to find among which will be the correct option. Okay, so in order to solve this, so this is the NPTEL reference. You can look into it. Okay, so let's solve this problem then. So what Sturm-Liouville problem is given. So let me first write that any general form for the Sturm-Liouville problem. So this is Sturm problem with periodic boundary condition. Right. So this is the general form. Any Sturm-Liouville problem with periodic boundary condition you can write like this: d dx of px dy dx plus qx y equals to lambda times wx y, where x is in some ab, and the boundary condition y naught, and at the point y pi this is 0. So at the point 0 and pi this is, or some ab, right? It will be here ab. It is 0, means that's why it is called periodic boundary condition. Here wx, this is called the weight, and yeah, so this is the general form for the Sturm-Liouville problem with eigenvalue, Sturm-Liouville problem corresponding to the eigenvalue lambda. So there is a theorem. It is saying that if the two eigenvalues are different, then the corresponding eigenvalues are orthogonal with respect to this weight. If you can write like this, then the corresponding eigenvectors means solution eigenfunctions corresponding to different eigenvalue are orthogonal with respect to this weight. So this, let me write the theorem. Let v1 and v2 be eigenfunctions of, let me call this to be the star corresponding to distinct eigenvalues lambda 1 and lambda 2 respectively. Then what it is saying, then v1 and v2 are orthogonal with respect to the weight So weight function, what is the weight function here? Is W. So with respect to the weight function W, what is the meaning of this? Means the integral of v1x and v2x, so bar into wx from a to b dx is 0, right? So basically saying that the eigenfunctions corresponding to two different eigenvalues are orthogonal with respect to the weight w. If you can write like in this form, the Sturm-Liouville problem, if it is in this form, then you can say that the eigenfunction corresponding to two different eigenvalues are orthogonal with respect to the weight w. So in our case we have this Sturm-Liouville problem. So we want to write like in the form in which the theorem is stated, from where you can deduce what will be the corresponding weight function, right? So here, what is the Sturm-Liouville problem? d2y by dx2 minus 3 dy dx equals to lambda y for the range x in 0 to pi, and the periodic boundary condition is y naught at 0 and pi, this is 0. So you want to write this problem in this form, right? So from we can do the other way. This we can also write in that form, then we can also compare. So this will be easier. Let's do this. So what is this general form? Minus d dx px dy by dx plus qx y is lambda wx y. So if you now differentiate with respect to by chain rule, so what you will get? Minus px d2y by dx2 minus p prime of x dy dx plus qx y equals to lambda wx y. Okay, so now assume here the px is non-zero, right? Means identically not equals to 0, otherwise then it will be some first degree differential operator. So here px is non-zero, assumption is there. So therefore let's divide it by px, by minus px. Then what you will get? Assume that here p dash x not equals to 0, px is not equals to 0 identically. d2y dx2 plus p prime x by px dy by dx plus qx by minus qx by p, right? Y equals to minus lambda wx by px into y, right? So now if we compare these two, so let me call this one, so not, let me call this one 1 and this one is 2. So if you compare equation 1 and 2, what you will get? So comparing equation 1 and 2, we get, so first is there is no coefficient, it's 1 1. Coefficient of dy by dx, it's minus 3 here, and here is p dash x by px, so therefore p dash x by px, so this is minus 3. And next there is no coefficient of in this side, so this is for the lambda, so that's in the other side, that's fine. And without lambda there is no coefficient, so qx by px is basically 0. Qx by px is 0, and the coefficient for lambda, here it is lambda y, here it is minus wx px, right? So therefore third one we get minus wx by px equals to 1, right? So from this one we can say that this is wx equals to minus px, and now we can, and from here you can say that from here you will also get, from here you will get qx equals to 0, and if you solve the first one, what you will get, so this is basically minus p dash plus px equals to minus 3. If you integrate, so integrating you will get log of px equals to minus 3x plus, let me write this constant to be the log c, so therefore you will get px to be the c e to the power minus 3x, right? So therefore from this one you can say that wx will be, so therefore because wx is minus px, so therefore wx is minus p of x, which is minus c times e to the power minus 3x, right? So we have get, or c is some real number, right? Or c is some real number. So we have get the wx will be of the form sum, so this basically you can also write some, let's write c tilde, so basically c e to the power minus 3x, c tilde is, no, some c is minus c tilde, so some constant times e to the power minus 3x, so this is the weight. So then this theorem is saying that if there are two eigenfunctions corresponding to two different eigenvalues, then they will be orthogonal with respect to the eigenvalue. So this weight, then weight will be c e to the power minus 3x. So therefore among which options these are correct? So 4 options are given, among which, so basically if this is, so the first one is e to the power minus 3x, second one e to the power minus 2x, e to the power 2x, e to the power 3x. So if some weight function are orthogonal with respect to this weight, because the constant is does not matter, you can always take it out. So 2, so eigenfunctions corresponding to two distinct eigenvalues are orthogonal with respect to the weight function because constant we can always ignore, because constant multiply does not matter. weight function wx equals to e to the power minus 3x. So the answer is e to the power minus 3x. So the weight function will be e to the power minus, means option A is correct. Okay.